All right, everybody, welcome back to the ESAB live stream. It is Thursday at noon, so we've gone live today here on the ESAB Welding and Cutting Facebook page. We had such a good reception from everybody, both myself and Bob Moffett. So first of all, I want to say thank you to everyone who tuned in to all the live streams that we did during National Welding Month. And we decided that since it was so popular, you know what, we're just going to keep throwing these out there occasionally, as well as I noticed that Madero was doing some welding art for the past few weeks, which is, if you ever get a chance to see what that guy can do with a torch, it's very, very impressive. So you can always go back and watch these live streams on the page anytime you want. They just sort of stack up in there. So today's live stream is all about plasma cutting. We've talked about welding, we talked about some different types of welding, MIG welding and TIG welding. We did some beautiful metal art with Madero, but we haven't done anything when it comes to plasma cutting. So we decided that, you know what, today would just be like a little introduction to plasma cutting here in the Big Tire Garage with myself. So first of all, some housekeeping items. Number one, if you see me looking over there, I'm still here in my shop all by myself working, doing this. That's my live stream mixer right there, so I got to look at that occasionally to see what's going on. And as I look over there, I realize that, I forgot to add the logo, which goes the official ESAB Weld-On logo, which is going to go right there. Look at that. Boom! Okay, so here we are as part of the ESAB Weld-On series. We're talking about plasma cutting. Second piece of housekeeping that I want to deal with today is ESAB Welding and Cutting is doing another giveaway. So what they're going to be doing is they're going to be giving away this is National Safety Month. So they're going to be giving away, the prize package is a Victor Performer outfit, oxy-fuel outfit, Sentinel A50 hood, gloves, and a welding jacket. So they're going to be giving that away. They're going to put the link to the entry, they're going to pin it in the comment section. So make sure you're paying attention to those comments, and you'll see that giveaway sort of pop up in there as we go. So we're going to jump right into everything here. So we're going to start with basically, hold on, let me get up my lesson plan. As you know, being a teacher, I like to have a lesson plan in front of me. So I got my lesson plan right here. So start off like we always do. We're going to talk about PPE, personal protective equipment, when it comes to plasma cutting. It's similar to welding, but not the exact same. Obviously, we're still going to wear long sleeves, long pants. It seems silly to say that, but a lot of people will be in their shop in shorts, but you should have long pants, closed-toe leather boots or work boots of some type of welding glove, and then obviously some safety glasses. You will also want to get yourself some type of tinted shade when plasma cutting. I have this little this G30 helmet, I should say, right now. It's actually a cool little face shield. I kind of like it because it's got two different. Let me see if I can get it on the little camera. It's kind of got two different. There we go. You can kind of see that right there. Okay, let's throw that over there. It's got almost two different shades on it. So you can see, I think this is like a 3 or a 5. I'm not sure. But then it's also got this one bad. Like, boom. You kick that down, and then you got double the darkness. So in case you need to jump on, do something that's a little too bright, I normally just use it with it all the way up like that when I'm plasma cutting. So obviously some type of tinted lens you want to have, similar to what you'd wear if you're using an oxy-fuel rig. One other item that if you're going to be doing a lot of plasma cutting, you want to get some type of fresh air or respirator. I'm not going to wear one today just because I'm going to do a couple cuts here and there. But if you're going to be doing a large amount of plasma cutting, you should definitely have some type of respirator or fresh air source. And that is because the dust and smoke that comes off while you're plasma cutting, you'll notice there's a lot of it. And you'll also notice that when you are plasma cutting around on the floor, it'll all get really slippery. And that's because the dust that comes off the plasma cutter is actually like a whole bunch of little ball bearings. And so you'll notice that the floor will get really slick in your work area. So make sure you're going to want to clean up after yourself a little bit more. Sometimes it's nice if you have the ability, you can actually build a little plasma cutting bin. I don't have one because normally if I'm just doing a lot of hand cutting, I'll just throw it on top of my plasma table and use that. But what you can do is get yourself a 55-gallon drum and put some grating over the top of it, and then cut into that drum. That way all that dust will just sit down in that drum and not get strewn about on the floor. For what we're doing today, I'm just going to be cutting off the edge of the table. So that's what we're going to talk. That's our PPE. Now, a plasma cutter itself, you get your plasma cutter. What I have here is the new Cutmaster 40i because I get all the cool toys, and that's just how it works. So that's what we're going to be using today. I have a couple 60i's in the shop as well, and a 60i is what runs my big fast cut CNC plasma table. But the plasma cutter itself is not the only item that you are going to need. Plasma cutter obviously needs power like a welder, but it also needs a compressed air source. So you need to have some type of compressor to run that plasma cutter. For light duty work, I have gotten away with using super small compressors, like little pancake compressors, but you want a large tank. I used to have, I don't think it's here anymore, I think I took it back to the house, big, like one from my local home center. It was like a little, I think 2.5 horse, little pancake style compressor, but it had a big like 30-gallon tank. And I would use that occasionally for plasma cutting. Works great out in the field as well. But here's one thing you need to pay close attention to. If you're setting up your shop for plasma cutting, you want to get yourself one of these systems right here. So this is a basically, it's almost like a cleaner and a dryer. So what we have here is there's a desiccant, I always say that wrong, desiccant bead dryer and a filter as well as a pressure regulator. Now, what those will do is they're designed to remove any contaminants and, more importantly, moisture from the compressed air. Whenever you have a compressor in your shop, in this shop now I have a big 2-stage 5-horse compressor. You might hear it kick off while we're working here today, while we're cutting. As that compressor compresses the air, it builds heat inside the air. With that heat comes condensation, and inside that condensation, when it gets into the plasma cutter, it does not really affect the operation of the plasma cutter, but it will affect the length of time that your consumables last. The cleaner, drier air that you can put through your plasma cutting torch, the better. So at the very minimum, some type of filter and or dryer like we're looking at right here. You want to have one of those in your shop if you can get one. Now, there is another option out there, and that is, I'm going to bring this up right here, and that is this right here. This is what's called a refrigerant dryer. A refrigerant dryer basically goes in line with your compressed air system. You would basically plumb your air compressor into the refrigerant dryer and then pull the compressed air out the other side. What the refrigerant dryer does acts just like a refrigerator. So inside that dryer is a small compressor that is cooling the air, and as the hot air comes in, the refrigerant dryer is cooling that air down. When it cools the air down, it helps remove the moisture from the air, and then the moisture just exits out the bottom. It also has another filter and moisture trap inside that refrigerator dryer. What you want to make sure is that the refrigerator dryer is installed as far away from your compressor as you want, because it only pulls a certain amount of temperature out of the air, and the compressed air that's coming out of the air compressor is going to be very hot. It's called coming off the head or the top of the air compressor. It will be very hot, full of moisture. If you put your refrigerator dryer right beside your air compressor, it's only going to pull out a little bit of the air. If you look at like body shops, what they'll do is before the air from the air compressor gets to the paint booth, they'll quite often run it like all the way around the building inside aluminum piping. They'll put some loops in that piping that'll go like up and down the wall, up and down the wall, up and down the wall, and that's designed to allow the air to basically get trapped on the bottom. Then they'll run it into a refrigerator dryer. Then they will run it into a large desiccant filter or beaded air trap before it goes into the paint booth for the paint gun to spray. In my shop, I have my air compressor on this side, and then the air line runs all the way down, all the way over, all the way back, and then it drops down into my refrigerator dryer, and the refrigerator dryer feeds the plasma cutter that cuts on my CNC plasma table. When I want to use my hand plasma, I just plug into any of the hoses, but if I'm going to be doing a very precise cut, I pull the line off the refrigerator dryer and I plug into it there. And that way I know I have really, really dry air going through my compressor. So those are the additional items that you'd want to have in your shop after you get your plasma cutter. Obviously, good air compressor and some way to keep the air dry. So now we're going to talk about basically the consumable items inside the plasma cutter. So hold on, I'm going to bring up a little, actually, we're not. We're going to talk about how a plasma cutter works first. So I have an image here. Let me just pull it up. So how a plasma cutter is actually very simple. It works very similar to a welder in the fact that it uses a small piece of tungsten that is embedded in the electrode and an electrical current to create a small arc. That arc is then forced through the nozzle, and then the system uses compressed air to blow the plasma stream through the workpiece. So basically, if you were to think of it in its simplest terms, what you're doing is you're creating your small arc inside the torch. The arc will actually jump out because there's a little piece of tungsten on that electrode. And then the compressed air is there to blow that plasma stream through the workpiece and allow it to cut. You can see, hold on, I'm going to see if I can bring one up here. This is the consumable pack. Came with my torch. I'm going to look to see if I have a new one that you can see the end of it on. There's an old one. You can sort of see it. There we go. What's that? Is that a good one? Oh, that's a better one. Let's see if we can see that one better. Okay. Let's go ahead. Get this set up if I can. That's going to be hard to see. Come on, focus. Oh, it focused for a second. There it is. We're going to try this, see if it works. We're really close to this camera. So you can see right here at the very end of this, if it will focus, there you go, very end of this electrode, you can kind of just barely make out that little glowing tip right there. That's a little piece of tungsten. That little piece of tungsten, it's not really going to pull back a little bit. Oh, come on, focus in. You can see that that is a small piece of tungsten that is embedded in the very, very tip of this electrode. That is what causes the plasma arc, which is then used to cut the material. Nice thing about a plasma cutter, really it's going to cut anything. You know, it's steel, aluminum, stainless, it'll cut it all, no questions asked. Very, very handy nowadays, especially in an automotive shop like this. Some newer cars have a lot of stainless exhaust from the factory. If you try to cut that with a torch, it's messy. The plasma cutter makes quick work of that. So showing you that little electrode, I got a better way to show you all the little parts of the plasma torch here, and that is an actual image that comes with your plasma cutter manual. So you can see here the little plasma cutter manual. On the right are all the different little parts and pieces. I have a sheet here that I can look at. That's what you're hearing. So if you look at this, this is basically a parts catalog of the torch. So you can see the electrode, that was the little piece that I was showing you. Electrode fits into the torch. Then there's a start cartridge that wraps around it. And then you have tips. You have different types of tips. You have drag tips, gouge tips, and standoff tips. We'll get to that in a minute. And then moving down, you have your shield cups. And then at the very bottom of this, you have your different types of caps. You have a deflector shield cap, drag cap, a gouging shield cap, and a mechanized shield cap. So those are the parts of the torch that you have inside your plasma cutter. And what I'll do is I'm going to try and lay these out so you can see them on the bench. We're just going to try and take this thing apart. I'm going to set up my little camera here. There we go. Okay, so I'm going to go ahead and take apart the actual torch for this plasma cutter, and you can see how each piece comes in there. So you have your torch. This is what the head looks like when you're using it. Basically, you can see the electrode, or the cap rather, protruding. So we basically obviously make sure the machine is turned off, unplugged when you do this. we're basically going to unscrew this large piece. There we go. There's that. Then you have your tip. So this is a standard tip that we have in right here. And then we have our start cartridge, which fits around that. And then we have our electrode that is inside of here. And it just pops out like that. So these two items, the electrode and the tip, these are your consumable items inside your plasma cutter. These two items wear out under excessive use because of the fact that you have that small little tip of tungsten inside of there that is blowing the arc through this tip, and you can see it starts to wear out over time. So if you are using the machine, these are the two replaceable items inside the torch head itself. And then all you have to do to put it back together is you can install your electrode, put your start cartridge over. There's a little O-ring in there that holds it. Tip goes on, and then the cover goes on. That's it. It's that easy. The machine will tell you if there's something wrong with when you reassemble that torch head. Quite often what can happen is while you're cutting, slag blows up inside the torch, especially if you're doing a lot of dirty work. A lot of people pick up the plasma cutter for just any job. It's just like, I'm going to cut the world apart with this bad boy. And so they're underneath the car and they're just cutting stuff and slag's dropping down in there. And sometimes you'll end up similar to a welder, a MIG welder, when you get a bunch of slag inside the nozzle and then your welding tip and the nozzle are touching each other, and it sometimes starts to energize the actual nozzle itself, and you'll notice that when you're welding. Same thing will happen here, but what happens is the machine will give you an error message to say, hey, there's something wrong inside the tip, and usually if you just take it apart, you'll notice it right away. Sometimes you just got to change out that electrode, change out that tip. So what I have right here is we have basically a standard setup on this. This is a standoff tip. So now what I'm going to do is I'm going to take you through just some basically how to cut. We're going to start with just how to cut with the plasma cutter. So the first thing we're going to do is turn the machine on. It's going to be really loud. I apologize. That's just the way it is. The fan's going to start running on that pretty quickly. Put my gloves on. Okay. I'm going to set up this camera here so you can kind of see a little bit better of the excitement that's going to happen here. There we go. I'm just going to cut right there. Okay, so put on my PPE. Got my little mask here. I got this one turned all the way up because we're cutting some, I think this is quarter. It's like 1/4 inch steel. Okay, so the process to cutting with this, oh, I gotta kick this over. And okay, so the process to cutting with this plasma cutter is we're going to keep the tip just about 1/8 of an inch away. You want to try to keep the torch as close to 90 as possible, unlike a cutting torch or oxy-fuel torch where you'll have a little bit of an angle to it sometimes to speed up the cut. If you do that, that actually slows down the cut because the kerf of the plasma arc is not going straight through. So you want to try to keep it as straight as you can, straight up and down, perpendicular to the workpiece. And then all you got to do is pull the trigger, get into position, pull the trigger. I'm going to arc it out here so you can see it. Just like that. And then all we're going to do is just cut straight down. It's really simple. Here we go. I'm going to set that over there so you don't have to listen to that sound. So the speed in which you cut, all you're going to be doing is just paying attention to the cut itself. It should be easy to see whether you're going too fast or too slow, because what will happen is if you go too slow, you'll get what's called a rooster tail, and that is where you'll see the plasma not cutting through. So I'm going to show you that right now. So we'll come back over to here. So we'll do a too fast one here. So I'm going to go this way so the sparks don't go up into the camera. So if I come across here and I start to go too fast, you'll see what happens. Oops, put that up there. So more steel to cut. So by going too fast, you saw the sparks basically just sort of bouncing off of the steel. That's called the rooster tail because it kind of looks like a rooster's tail because it's like coming off the back of the cut. That just means I am going too fast. I may be too far away. At that point in time, you just have to slow down, check your standoff from the metal, make sure you're not too far away, too close, and travel at the correct speed. Another popular item to do with the plasma cutter is going to be piercing a hole. So what I'm going to do is I'm going to draw a little hole on this piece of plate. So it's got my paint pen here. Got it fired up, get it all full of paint. There we go. So I want to cut a hole. Very common thing to do, cutting holes with the plasma cutter. So, my glove back on. What I don't want to do is I don't want to start my hole at the edge because that is the important part of the material. If this was a perfectly designed hole or perfectly measured out hole and I wanted to stay on the inside, what you want to do is you want to pierce in the middle, work your way out, and then we'll work our way around the hole. So something like this. You start with the torch above the material, still perpendicular but fairly high up, and then put it down in. Once it's through, over. That. If it's still hung on, just give it a little tap. Oops. There we go. So that would be how you would cut a hole. It's a little bit of a messy hole. I apologize, that's because I was standing over here when I was doing it. But basically pierce towards the center, work your way out to the edge, and cut around. So cutting straight lines. Sometimes that's a little tricky because you are basically just pulling or pushing the torch. I like to always pull it or move it in an arc. So the best thing to do when cutting a straight line, get yourself straight edge. In this case, I have this piece of angle iron. What I'm going to do is I'm going to set the angle iron down onto my steel. So what I would do is I would place the torch up against the side of the angle iron, and then all I'm going to do is I'm going to use it as basically a scribe or a guide to cut a good straight line. Just like that. That's a pretty sweet little cut just for a little 40 amp plasma cutter. You can see the cut on that. Can you see the cut on that? Yeah, there you go. That's a nice little cut. Fairly thick piece of material for this little cutter. One of the nice things about this particular 40i is it's dual voltage, so you could also plug it in to 110. I actually had it plugged into 110 cutting some 8 the other day. It actually worked very well. You can see that if you look back at this, let me show you. You can see how this, so this was the cut, came off of here. If you look at the end of this, you can kind of make out, let me see if I can get it set up right, the curve. This is called the kerf of the cut. And the kerf of the cut, this side is basically perfectly straight up and down, and this side has a little bit of a curve to it. And that's because if you were to look at that plasma cutting arc, there is going to be a straight side to that arc, and then almost a rounded edge to it. And depending on how the torch is set up, you're going to want to experiment with that, making sure that the straight edge is always on the side that you are going to be working towards for your good quality cut. So that is a straight line. Let's talk a little bit about an arc. This isn't big enough to cut an arc on, so I'm going to move this. Move some of the steel out of the way. Okay, move that over here. I'm going to move this piece of steel here. Okay, so what I have right here is a piece of aluminum. Okay. Now, if I wanted to cut maybe like a nice little arc in here, like a, wait, you can't see that. I'm drawing with my finger and you can't see. So if I wanted to cut an arc in here for whatever reason, maybe it was a decorative element that I was making, or I just wanted an arc. What I like to do is I keep a lot of these around. These are little flexible rulers. Let's get them at the home center. They're cheap and they're somewhat disposable. And then what I do is I basically get a pair of vice grips. And I'm going to use this as sort of the anchor point of my arc. So what I'm going to do is I'm going to place the vice grips on the piece of metal, like so. And then all I have to do is, you can kind of see it in the big picture there. You can't. I'm going to switch over there to camera. So the vice grips become the anchor, and then all I do is I just bend this steel ruler. It's an aluminum ruler because it's flexible. I just bend it, and because I'm bending it, it's going to give me an incredibly smooth arc. Like if I tried to draw that and freehand that, there's no way I'm going to get it that smooth of an arc, just because of as you bend this, it kind of naturally turns into this shape. And then all I do is use the ruler itself as the guide. So this becomes like a two-handed operation. So my left hand is over here on this ruler, and I hold it like this, and then I just basically freehand this down like this. So it looks like this. I got a little sloppy there with it, but you can see that I can get a good arc out of that. That was a little sloppy. Let me try and do that a little bit better. I apologize. I'm going to bring this down a little bit. Put this in here like this. There we go. Oh, I missed the spot. We're going to do that one more time. This time I'm going to try and run it at the right speed here. Okay. Here we go. Try it one more time. Here we go. Hopefully I can get it right this time. There we go. That's a little better. There we go. Now we have a nice smooth arc all the way down and a nice smooth arc on this one. What happened on that first couple of cuts, just waiting for that air compressor to kick off. There we go. What happened on those first cuts was same thing that would happen if I was welding. I didn't make sure that I was in a comfortable position before I started cutting. I just grabbed it and started cutting. You want to make sure that you can get all the way through the cut smoothly. So it's always a good idea to do a dry run of the cut before you cut. I didn't do that on that first cut. That's why it was sort of all over the map. But that's 100% my fault, and I will take full responsibility for that. So let's just make sure we've gone through everything. Curve, circle. So I showed you how to basically freehand a circle, but there is another way to cut a circle, and that is to use a little piece of TIG wire. I don't think I have one here. Hold on. Grab one out of here. Nope, not that one. There we go. So another way to cut a circle is the exact way that we cut this circle before, and that is to make a little circle guide. So I don't know if I'll be able to make it. I'm going to try and do it. We're going to see if I can make it on this one or not. Basically, you're just making a little roundabout thing for your torch. So I'm making a little loop at the end of this piece of TIG wire, like this. Okay. And then what you would do is you would take the other side of the TIG wire and you would basically make it the anchor of where you wanted the circle to be cut. So I don't think I have enough material here to do this. Let me see if I can make it really short. I don't know if this will work or not. Kick this over to the, let's merge this over. You can see what I mean? So basically what I have is a small little guide, and then all I'm going to do is use this to make my circle. Let me see if, I don't know if I'll be able to make it work on this piece of scrap that I grabbed for this lesson, but let me just see if I can. Let me see. If I put that there. You know what? I might be able to pull it off. Let's give it a shot. Let me clamp this thing down the bench so it doesn't go anywhere. I'm going to be hanging it off pretty far. Okay. Let me trim this. Got a pair of cutters here. Go. Now, there's a couple ways to do this. You could tack weld this. You could put a screw in here for this if you wanted to. Fasten this side and then work your way around. I'm going to try and just hold it with my finger. I don't know if I have enough stuff here to get all the way around. Hang this off the edge a little more. You know what I'll do? I'll just do like half circle. Do a half circle. I'll do like this, and you can get the idea. Now we can just cut that edge off right there. Okay, so basically what I'm going to do is I'm going to hold this end, I'm going to lock the tip into this other end, and we're just going to sort of do a little half arc, a little half circle right there on the edge of this piece. You can see what I mean. So I'm going to grab this, lock this in like so. Oop, popped out. Now I lost my little thing. There it is. Okay, hold on, I gotta wrap this around here tighter. There we go. I should probably get it. I'm gonna try and get that locked in there a little bit tighter. So, doesn't pop out this time. And you can see how if this was being held in place, you could just go all the way around in a circle and get a completely finished circle. And that's just sort of quick and easy way to get that circle done. You can buy circle cutting jigs that attach in place. Same principle, basically drops this torch down inside of it, and then you can just basically pull it all the way around. You can also get some different tips. You get a drag tip, which would rest directly on top of the material, and all you have to do is pull it across. And then you have what's called a machine tip, and the machine tip is designed for any type of mechanized plasma cutting, which would be like a CNC plasma table. Go ahead and turn this thing off. Okay, so that's pretty much introductory to plasma cutting. A couple little tips. One that I use the most often is going to be this straight edge for getting straight cuts, and then this piece right here, these rulers. This is a great thing to have. You can just make any arc shape that you want, quick and easy. Another thing that you could do is if you already have some items that you've cut out of common shapes that you want, you can make guides. If you wanted to make if this was your arc guide, you could now use this piece as the guide to basically duplicate that arc. You would just use the edge of the piece. Let me get a close up of that. You could just use the edge of this piece and basically cut using the edge and using this as the guide instead of the large shield as a guide, just basically using the edge of the electrode as a guide. It's one way to do it. You want to make sure, this is not a good example because it's aluminum, because it's going to gall up as you go. Make sure that you grind it good and smooth if that's what you're going to do. Okay, so what I'm going to do right now is I'm going to jump back over onto the ESAB Facebook page, see if there's any questions and or comments that we need to address. Let's see. Does this model have a high frequency start? I don't know if this is a high freq start machine or not, but this is just a how do you weld cast iron. That's a completely different video. Wow, we got a lot of people from all over the world watching, which is great.